Hi, today I'm going to go over a brief overview of the Fama French three-factor model. You may be familiar with the capital asset pricing model and its use of one factor, the market premium or the market risk factor. What the Fama French three-factor model does is it includes an additional two other factors to calculate the required return on equity. The factors for the Fama French three-factor model include the market risk premium, which is the premium that's included in the capital asset pricing model, but it also includes a size premium, because in their research they found that small firms tend to have higher returns or require higher returns than large firms because they're riskier. And then the value premium, which shows that firms that are have high book-to-market values or low market-to-book values, those might be undervalued in the market, tend to earn higher returns. To that, just like in the capital asset pricing model, we add a risk-free return to calculate the required rate of return on equity using this model. The way that it works is it looks something like this, where the return for the individual firm is equal to the risk-free rate plus a beta or a correlation coefficient for the market, which is the market risk premium that you might be familiar with. The notation here stands for the return for the market less the return on the risk-free asset, plus a correlation coefficient of beta for the size of the firm. And this second item is a size premium. It stands for small minus big. So the return on a portfolio of small firms minus the return for a portfolio on big firms. And then finally, the last one is the value premium. The beta is the correlation coefficient for the value risk premium, and the value risk premium is calculated as the return for a portfolio of high book-to-market value stocks minus the return on a portfolio for low book-to-market value stocks. The betas are calculated for each firm using multivariate regression, and I'm going to give you an example of that in a minute. And then, so we calculate the betas and we multiply them by these risk factors, which will be provided for you in this tutorial. So for an example, after we calculate the correlation coefficients for each of these risk premiums, we can then calculate the required rate of return for the stock. In this case, we have a risk-free rate of 3%, an equity risk premium of 5%. So in terms of the capital asset pricing model, this would be your beta, or excuse me, this would be the premium on the market. The beta in this case would be the beta from the capital asset pricing model. However, we're not going to calculate it the same way again. We're using multivariate regression to include the effects of including the size premium and the value premium in the regression. So the size premium would be 2.2%, and the size beta, the sensitivity of this individual stock to the size premium or the size risk, of 0.12, a value premium of 3.8, and again think of that as that risk premium that we often use for the capital asset pricing model, and then a value beta. Again, this is the sensitivity of the firm to that value premium and that value risk. Okay. So our calculation is pretty straightforward. After we calculate the correlation coefficients, we can then multiply them by the risk premiums, 5%, 2.2%, and 3.8%, to get the required rate of return for the firm using the Fama French three-factor model. The benefit of the Fama French three-factor model over the capital asset pricing model is that it includes these size and value premiums that aren't captured in the capital asset pricing model. Research has found that this tends to be a little better estimate for the cost of equity for a firm. And so now what I'm going to do is give you an example of calculating the Fama French three-factor model. So I put together a spreadsheet. This spreadsheet is from Kenneth French's website. Kenneth French is half of the partnership of Fama and French, and he updates these risk premiums and these for the three-factor model on a monthly basis. What we have here are the monthly premiums through the beginning of October 2012. So you could think of this date as October 1st, 2012, and so the negative 1.44% is the market return minus the risk-free rate between September 1st, 2012 and October 1st, 2012. Kenneth French and Eugene Fama calculate these every month based on, again, in the first case, this is the size premium, small minus big, and they take a portfolio of small firms and subtract the return from a portfolio of big firms from that to get the size premium, and this is the high minus low, or the value premium. And then what they do is take a portfolio of high book-to-market value firms and subtract the return from that subtract the return from low book-to-market value firms from the returns from the high book-to-market value firms to get the risk premium. Finally, we have a risk-free rate. This is the monthly T-bill rate for that month. And what we're going to do is find the returns for a specific stock, calculate the excess return. And so this is a little bit different than how we calculate the capital asset pricing model. But we're going to calculate the excess return for the stock over the risk-free rate and then regress that on these three variables. So the company I'm going to use is Ford. So what I'm going to do is go out and get the returns for Ford stock. And as I mentioned before, the returns from the Fama French model that are provided by Kenneth French, the dates are for the kind of the return for the preceding month. So the return for October 2012 is the return from September 1st through October 1st. So I want to match my dates up with that, and I'm going to use 5 years of monthly returns. So my start date is going to be September 1st, 2007, and my end date is going to be October 1st, 2012. So once you do download those, you'll get something like this. I'm going to download this to a spreadsheet. And so this is what it gives me. This is the spreadsheet for Ford returns. Again, they end October 1st, 2012. The open on October 1st, 2012 was $9.89. The high was 10.08. The low was 9.88. The close was 9.93. This is the volume of shares traded that day. And what I want to use is actually the adjusted close. What the adjusted close does is it includes the effect of dividend payments. So it includes what we refer to as the total return, the return from both the increase or decrease in the stock price plus the effect of paying the dividends. So it's going to include that dividend yield in the end prices or the end returns that we calculate. So I'm going to go ahead and calculate the returns for this period. The way I do this is I put in the Excel function ln for natural log. So I'm going to take the natural log of the most recent price divided by the price in the prior period, and that gives me a compounded return. It's very similar to the holding period return that you might be familiar with, which is the adjusted close minus the previous adjusted close divided by the previous adjusted close. The difference between the two is that this the natural log assumes constant compounding of the returns and tends to be a little bit more accurate. So I'm going to go ahead and pull that down all the way. The last one, could be an error, so we'll take that out. And then I'm going to copy and paste that. Oops, don't want that. Let me try that again. There. I copied and pasted the values. This is for Ford. I'll make it look nice. Now I'm going to calculate the excess return, but because what we're going to do is regress the excess return on our three variables. So the excess return is equal to the return for Ford minus the risk-free rate for the period. Okay. So now what I'm going to do is complete my multivariate regression. To do that, you may need to go out online, or excuse me, not online. You may need to go out and actually add the toolpack for the data analysis toolpack. If you've already got it in there, you can select data and go to data analysis. What I'm going to do is go out here just to show you how to access it. You'd want to go out to options, so I press on file and then options, and then go to add-ins. Go down here to manage Excel add-ins. And if it's not already checked, you'll want to check Analysis Toolpack. That'll give you access to data analysis. So in data analysis, I want to go to regression. So I'm going to scroll down to regression and press OK. My Y input range will be, in my case, G1. And then notice that I'm highlighting the label, and I'll show you why when we actually calculate the regression. I'm going to pull that down all the way. And then for the X input range, I'm going to select B1, which is the market risk premium, through D1, which is the value risk premium, and pull that all the way down to the end of my time period. And then you want to select labels. That's why we highlighted the labels at the top, so that our results are labeled. Okay. Once you have that, your regression screen should look like this. And this gives us our results on a new page. So those coefficients that I mentioned before are these values here. The R-square provides a statistic on how well the model actually fits the returns that we see, the actual returns we receive for Ford. It's not great. This model predicts about 41% of the variation in Ford's returns, so it's not great. It tends to perform a little bit better than the capital asset pricing model, though. Alright, so the last step is to actually calculate the required rate of return for Ford stock. So the first thing piece of information we want to include is the risk-free rate. And I use the yield on the 10-year U.S. Treasury. I use the yield on the 10-year U.S. Treasury because I see a stock as a long-term investment, and I want to match my risk-free rate to my expected investment horizon. So I'll go out to Bloomberg.com, to get this piece of information. I go to Market Data and U.S. Treasuries, and the yield on the U.S. Treasury is currently 1.57%, so I'll include that here. And then the first item is the market risk premium. So I'll start off by including the market risk coefficient that we calculated. And that would also You could also call that the beta. And that's equal to the coefficient for the market risk, the market return minus the risk-free rate, or the market risk premium. For Ford, this is high, and it's high because they are sensitive to interest rate risk because they have a lot of debt, and it's high because they're also sensitive to fluctuations in fuel prices and unemployment. The market risk premium that I'll be using is 5.5%, and this is based on the market risk premium for the time period 1980 through 2006. I like that cutoff date because it precedes the housing market bubble bust and the resulting recession. So it represents a more normal time in the marketplace. Just formatting that a little better. The second premium we're going to use is the size premium. So I'm going to include here the size risk coefficient. And that's going to be equal to 0.036937. The size risk premium that I'm going to be using is 0.02. Again, it was calculated between 1980 and 2006. All right, so we have the risk-free rate, the market risk premium, and the size risk premium included. The last item is then the value risk premium. We'll add in our value risk coefficient, and that's going to be equal to 0.538, and then our value risk premium, which is equal to 0.043. Where I got this information for the market risk premium, the size risk premium, and the value risk premium is a textbook called Equity Asset Valuation. The authors are Gerald Pinto, Elaine Henry, Thomas Robinson, and John Stowe. It's the second edition of the book, and its publication date is 2010. In case you need to cite that anywhere in your report. So, using all this information, we can calculate the required rate of return for Ford, and that's going to be equal to the risk-free rate plus the market risk coefficient multiplied by the market risk premium plus the size risk coefficient multiplied by the size risk premium plus the value risk coefficient multiplied by the value risk premium, which gives us an answer of 15.482%. Okay. And that's it. That's how you would calculate the required rate of return using the Fama French three-factor model. A couple of other things to point out is the information here on the p-values. For Ford, we see that the market risk premium is statistically significant. It's very small. However, for the size and the value, the p-values are quite large and would not be considered to be statistically significant. Please let me know if you have any questions. I will send you a link to this data for the market risk premium, the size risk premium, the value, and the risk-free rate along with this video. Thanks.